Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this problem, lexicographical numbers. That is Leetcode 386. This problem tagged as a medium, and I feel so it's an indeed medium problems. Like a very general patterns we can incorporate to get an easy. Yeah, so given an integer n, return all the numbers in the range of 1 to n sorted in lexicographical order. Just a one-liner and very straight and very like all are we are going to able to digest it. There is no super English they have written altogether. Yeah, and this is the follow-up. This is the follow-up. So always try to solve. Na? So if a particular question giving you a follow-up, then try to solve it with a follow-up. So there may be some loopholes you can solve it without that follow-up and happy to get an AC. But never do that, because on interview you will, maybe your interviewer is going to ask to with the follow-up, because if you are able to solve the question with all the follow-ups they like Leetcode is giving you in upfront, then do it, because that is the most optimized time and space complexity, or I have to say, like in more constant or rigorous algo you have to write it to get the AC for this particular problems. But there are some loopholes algo is also going to be there which we are going to get an AC, but never opt for that until you are not able to get an AC with the follow-ups. Yeah, so the follow-ups for this question is we have to get it in time complexity of big of n and space complexity of big of 1. So if you can going to understand the problem statement, like on the sample test case 1, so we have 13. So for 13 we have to return them all the numbers from 1 to n, that is bound to be in the list we have to return, but like we have to return in lexicographical order. So lexicographical order means between, so here you can see 1, after 1 we have 10. So that means between 10 and 2. Between 10 and 2. So after 1 we are expecting 2, because 1, 2, 3, that is the pattern. So we are like reading from childhoods or learning from childhoods. So from 1 we are expecting to 2. But here you can see after 1 we are going to get 10, right? After 1 we are going to get 10. So the comparisons between how actually 10 own with 2. How actually 10 own with 2. So between 10 and 2. Now if I can go to my OneNote quickly. So I think you guys are following lexicographical order, but if you don't know, then let me just quickly give you a gist on high levels. So what actually I am stating, between 10 and 2, right? Between 10 and 2, it is going to check, it is actually setting the 2 pointers to the very start. So one pointer is here and another pointer is here. So if both are same, let's suppose I am going to check 10 and 11. So 1 is same. So no win. Now we have to move our pointer to next, like 0 1 same. 0 1 delta. Who is smaller? 10 is smaller. So 10 is lexicographical smaller. 10 is lexicographically smallest, and this one is lexicographically largest compared to 10. And 10 is smaller compared to 11. But for 10 to here you can see on the very first index there is a delta. Who's small? This one is small. So 10 should come prior of 2. So 10 should come prior of 2. So it should be 10 is smaller than 2. 2 is greater in lexicographical order. But in normal number theory, 2 is smaller than 10. But in lexicographical order, 10 is smaller than 2. So that is the gem on this particular problems. Rest I think things are very straightforward. So here you can see 1, 10, 11, 12, 13. Then I am going to get 2, 3, 4, 5, 6, 7, 8, 9. Right. Now for n equals to 2, it is for simplest for sure 1, 2. So, and your constant can big as 5 into 10 raised to the power 4. That is the largest constant, like your n can be 5 into 10 raised to the power 4 from 1 to n. That is the range of your n, right? So now if you can focus on this particular constant, so 5 into 10 raised to the power 4. So that means how many digit is there in 5 into 10 raised to the power 4? So if I am going to write it in the form of this 5 into 10 raised to the power 4. So after 5 there are 4 zeros. So how many digits? 1, 2, 3, 4, 5. So there are total 5 digits. Right? There are total of 5 digits for sure. Now if how we can generate in numbers in lexicographical order. So as we have 5 digits. So first digit is never going to be 0, right? This digit, who is the first digit, is never going to be 0. What is the range for this? It's for sure 1 to 9. Yes, that is the range for first digit. For rest all, What is the range? It can from 0 to 9. It can from 0 to 9. All are in from 0 to 9, right? Agree guys? Totally agree? All the numbers who are just after that, just after the very first digits are in the range of 0 to 9 only. In the range of 0 to 9 only. The first digits is in the range of 1 to 9. Now, I personally feels like I have used my own template here to basically if you are playing with your digits to generate the numbers, then let's iterate to all the digits. Let's iterate to all the digits and write a nested for loops to for digits, because our digit is very small. Because how many for loops we have to write? How many for loops we have to write? 5 for loops we can write. 5 for loops we can write. Yes. So we can write 5 for loops. Right? 5 for loops. So in the order of the first for loops is going to set the first number, the first digit. Second for loops is going to run to generate the second digit. Third is this, like this order. So if we can try to write the pseudocode. So these things is clear, guys. Agree guys? These things is clear to all of us. First digits is in the range of 1 to 9, because first can never going to be 0. Then the number is altogether not formed. Yes, because our range is from 1 to n. If we are putting zeros initially, then we are altogether going to sorted by one digit. Like we are shortening our digits generations by one digit. So the first digits never can be 0. The first digit should start from 1 at least, because our range is from 1 to n. The second digits has its boundary 0 to 9. You can go for it. So now how we can generate it? So I can write a simple 5 nested loop for in digits. A is going to run for first digits for a in range of 1 to 10, because Python is taking the last index as exclusive. I am repeatedly stating in all the videos, so I am iterating from 1 to 10. That is actually Python is running your for loop from 1 to 9. And inside that, if can I write it? If my a, the current digits, is less than equals to my n, so we definitely have an answer initialized here. That is an empty list for sure. That is my answer. And if my a is less than equals to n, so that means I got a 1, right? I got a 1. So I can, so that is the first digits and a single digits. I can do answer.append, this number, this a for sure, right? And if it is so, if my current digits is smaller than my n, then I can try what I can try. So that means if I am at 1, what is my next digits? It's not 2. It's nothing but 1 into 10, right? 1 into 10. The next digit should be 1 into 10 plus 1. So if I can write it 1 into 10 plus 0, then I can write it 1 into 10 plus 2. Like this way I have to generate. Then only I can. So 10, 11, 12, 13. These are smaller than my 2, right? If my first digits I am setting to 1, then I have to go from 0 to 9 to all the numbers to the second digits. Then only I am going to allow to set the first digits. And I know my a is running on the first digit. So when I am at 1, so if I can generalize this formula, so that is nothing but a into 10 plus b, so on 0, 1, 2 like this I have to run till 19, right? 10, 11, 12, 13 like this 19. So this for loop, so we definitely write a for loop here. So if that is smaller, then I can start a for b in range. Get this guys. So that is actually the intuitions. So please follow this algo. Like please be careful on what we just explained here, or what we are just writing on the very initial goal. Because when you are able to write till b, then c, d, e just a cakewalk for you. Like other digit setup just a cakewalk for you. Just a wrapper of already the 2 lines that we have just written. So b loops should run from 0 to 10, because on second digits we have from 0 to 9 we have to iterate. So 10 is exclusive. So now my current is what it is a into 10 plus b that we just saw. So that is my generalized. And if my current, if I can write it current less than equals to n, then that is the next lexicographical number. So I can push it to my answer. So I can push the current. Yes, I can push my current. Answer.append current. And if it is so, now for C also we have to play the same game. So we can start a C loop for C in range, right? For C in range, where? For C in range from 0 to 10. Yes, totally agreeing guys, totally agreeing. And now my current should be, now my A is at 100 place, because that is a 3 digits number we are considering. So we have to create 3 place, plus B should be in 10th place, plus C, yes, plus C. And if similarly, if my current is smaller than my n, then I should take it to my answer. dot append, right? To whom? My current. I should take it. And tell me I should start another for loop for d in, tell me, d in range again 0 to 9, sorry 0 to 10, again 0 to 10, so that is of 0 to 10, right? So again I have to build my current. Now tell me, this time my current should be a into 1000, right? B into 100 plus C into 10 plus D. So that is my current now. So if my current is less than n, then I have to push it to my answer, because that is the lexicographically smallest number I have generated. See guys the pattern, guys. So that is the beauty. So that's the reasons I have asked you to follow the A and B jump. Then rest of this just a patterns you have to follow. Code is itself is going to tell you what you have to do. If you are able to write the initial statement, initial jumps, initial go, initial like for recursions, what is the like terminal conditions, what is the base case. So these things are only important for any algorithms in all over the world you are writing. So if you are able to make your starting transitions in the correct node, then rest code it itself going to tell you what you have to do. So now if it is smaller, then we have last loop for e in range, again from 0 to 10, and my current is altogether going to be a into 4 zeros, not 1000, it is 4 zeros, plus b into 1000 plus C into 100 plus D into 10 plus E. Now that is the current. Now again, if my current is less than equals to my n, then please push me answer dot append current. So like this way we have generating the numbers in the lexicographical order, and let's suppose in the else block. So here you saw, right? So every for loops, so this is the nested one for loop, right? When we are starting it, when I am inside if the current is altogether smaller, then only we have to append one more digits to it and try to generate all the possibilities. But if my current is altogether greater than n, then I should break it out. So this is going to be applicable for first nested if. So if current is greater, then break it. And now this for loops is going to run inside this if. So like this, if I am going to go down, so if that is not in if, then on else, break it. And if I can go up, so there is one more there is like two more for loops when we are going to start it. So that is another if. So when this is going to be agreeing, then only we have to start it. And if it is not, then also we have to, tell me guys, then also we have to break it, right? So like this way, I think there is only one more for loop is pending, so that we can just see in the code iterations. So I think you guys want get the gist on the high levels. Now we can quickly discuss the code iterations part we can complete, so that you can get the more better gist of it. So that is the exact like hierarchical code that you can see, like there is a complete triangles that we are able to form here. So I think it is self-explanatory, and you guys is already the same things that I have just explained that I have written in the code. So answer is empty list. A is if from 1 to 10 we are iterating, and for all the nested loops, B, C, D, right? B, C, D, E, all are iterating on 0 to 10 only. First one is iterating from 1 to 10, so that means 1 to 9, and rest all are 0 to 9. If my A less than equals to n, then answer dot append A. Start your D loop, same A into 10 plus B. Same things I have just what I have explained on the one note I have written. Answer dot append current C. If that is so, then start a C loop, A into 100 plus B into 10 plus C. If it is satisfied, then start a D loop, A into 1000, B into 100, C into 10 plus D. If that is satisfied, then start a E loop, A into 10 raised to the power 4, B into 1000, C into 100, D into 10 plus E, right? And if that is in the boundary, then push this to your current. And if it is not so, right? So I think here also I can write it another else block. If that is not so, then also we can break it. And if so, here like that is the else hierarchical outgo, we have to just incorporate this for this. If that is the else, if that is not so, then break it out. If that is not so, break it out. If that is not so, break it out. If that is not so, break it out. And that is for final. If that is not so, break it out. And finally we are returning our answer. So yes guys, so that is all about the problem statement. And if we can quickly discuss the time complexity now, let me just submit this out. Yes, it is kind of bound to be the most optimized time you can achieve. So if we can quickly discuss the time complexity here you can see we are for sure iterating for big of n. How? So Shouvik, you have written 5 nested loops and every once is iterating from 10 times. So it is going to be 5 into 10 raised to the power 5 for sure. That is a 5 into 10 raised to the power 5 for sure. In naked eyes we are able to see, but no man, because we have this else break, we have this else break outgo, we have this else break outgo. So it is never going to be iterated in 5 into 10 raised to the power 4, 5 into 10 raised to the power 5. It is max only iterating for n times only, in n times only, because we have this else outgo, we have this else outgo. So it is going to break it for sure on that particular time. And on space perspective, do you guys see we are using any extra space? No, we are using exact in the follow-ups they are looking for. It is indeed a space complexity of big of 1 for sure. Can Leetcode predict our code time complexity? Can you please do it? Server is busy. I mean, every time I am submitting that times. Time complexity is big of 1. okay. Like Leetcode is too grateful to our submissions. They are giving our time complexity is big of 1 only, but that is not so. It is a big of n. So that is not helpful actually. So it is big of n. So but Leetcode is giving us big of 1. So that is not correct because we are generating all the numbers right from like till n, right? 5 into 10 raised to the power 4. We are generating all the numbers. If it is a constant, then how it is going to generate the number? So yeah. So it is not able to catch it. So it is stating big of n. But on space perspective, you can see it is 92% faster than all the submissions. Okay, on space perspective, it is giving big of n. Yeah, because we are using our answer list to return it. That is for sure. But here on the example test case, time and use and big of 1 extra space. So that means they are not basically incorporate what it is, the output space altogether. The output we have to return that they are basically omitting, because anyhow we need an answer list, right? So in that case we can write it in big of n. That is for sure, because to return our answer we need an extra space. Yeah, so that is bound to be the most optimized time and space complexity you can achieve for these particular problems. And if you guys are able to understand, so I have explained the detailed intuitions that I am able to think of for these particular problems in our OneNote, and the exact template that I am generally follow to this type of digit play games kind of problems, So here you understood, right, why we have to play with the digits, because when in the comparisons between 10 and 2, who is on 10 is win in coming to pad of 2, right? So that means there is a digit comparisons we are doing. So where actually the digit comparisons we saw, right, in our OneNote. So if we can go to between this explanation, so this is nothing but a digit comparison. So on digit comparisons, if you have the opportunity, your digits in the range of like 10 raised to the power 8, 10 raised to the power 9. So that means you can write 9 or 8 nested loops all together, and in between them you can generate your answer. So if you have this opportunity, then I personally feels to write the code on that, because that is kind of more granular or more readable, so more modulars. I like to write it, and also easy to debug. So yes guys, so that's it for this particular problem solutions that I am able to think of. And if you guys are able to understand till this point, so I guess you guys are already doing. So please do subscribe to our channels, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Happy weekend. Let's meet tomorrow with another beautiful person. Bye guys, bye.